Hello students, my name is Dr. Rituparna Saha. I am an assistant professor from the Department of Life Sciences, Christu Jayanti College, Bangalore. And today I am going to be discussing Introduction to Atomic Structure. When it comes to atomic structure, an atom is a small unit of matter and it is made up of three subatomic particles. There is the negatively charged electrons which revolves around the nucleus of the atom. There is the positively charged protons which is present within the nucleus and the no charged neutrons. Now these subatomic particles can be referred in the form of like this, where X is the symbol of the element, A denotes mass number and Z denotes atomic number. Now the mass number and atomic number are generally defined as, whereas atomic number is always equal to the number of protons, which is always equal to the number of electrons present within an atom. Similarly, mass number is always equal to the total number of protons and neutrons that are present within the nucleus of the atom. A variation of the atomic number and the mass number are isotopes and isobars. Isotopes are atoms with identical atomic number but different mass number. For example, isotopes of hydrogen, isotopes of carbon, isotopes of oxygen. Whereas isobars are atoms with same mass number but different atomic number. For example, isobars of nitrogen, argon, potassium. Now, all of this atomic structure and the study of the subatomic particles, it started with the discovery of electron by J.J. Thomson. J.J. Thomson performed an experiment with the help of a cathode ray tube, in which he passed a cathode ray and placed perpendicularly arranged magnetic fields and electric fields on the path of the cathode rays. From this experiment, the observations that he made was, number one, that the cathode rays always flows from cathode to anode in a straight line. The rays are not visible as such and can only be detected by fluorescent or phosphorescent materials. The cathode rays are always negatively charged, and that the cathode ray particles are present in all matter. And when the cathode rays strike the metal foil, it becomes heated, showing that cathode rays produces heating effect. And also, cathode rays shows penetrating effect and can ionize the gas through which they pass. From this, he devised and concluded that when electrical or magnetic fields are applied perpendicular to the path of the charged particles, they deviate from their path, and the amount of deviation depends on three factors: the magnitude of the charge on the particle, the mass of the charged particle, and the strength of the magnetic field or the voltage applied across the path of the charged particles. From here, he derived the charge and mass of electrons through the formula E is to m, where E is magnitude of the charge of electron in coulombs and m is the mass of electron in kgs, which he calculated to be 1.75 into 10 to the power 11 coulomb per kgs. Now, when it came to be Ernest Rutherford, he modified J.J. Thomson's experiment by ultimately utilizing alpha particles and placing a gold foil on the path of the alpha particles. From this experiment, he observed that a large fraction of alpha particles pass through the gold sheet without getting deflected. The positive charge in an atom is not distributed uniformly and it is concentrated in a very small volume. And only few alpha particles, when bombarded, were deflected by the gold foil, and they were deflected very minutely and at very small angles. Very few alpha particles had deflected at large angles or deflected back. Moreover, very few alpha particles had deflected at 180 degree. Therefore, he concluded that the positively charged particles covered only a very small volume of an atom in comparison to the total volume of an atom. From this, he ultimately proposed the Rutherford's nuclear model of an atom. His main postulates were the positive charge and most of the mass of the atom is concentrated in a small region of the atom which he called nucleus. The electrons surrounded the nucleus and moved at a high speed around the nucleus in circular paths called orbits. And the electrons and nucleus were held together by electrostatic forces. Thank you.